All right, ready to go? I already have most of you here. I'm really happy, guys. You know, the way you guys respond, the way you guys join back, I'm really impressed. You know, hats off to each of you. So pat yourself on your back, each of you, okay? I really like the way you guys are responding on chat, the way you guys are very attentive and joining back so quick. Appreciate it, okay? Very good. I think we pretty much have, we had 19 people. I think we have about 18 now, so we can keep going. All right, let's go back into the exam. Okay, so starting back, so we are talking about random access. So what random access does is it computes our address location randomly. So I don't know what is address. See, in self-addressing, I can compute my own address. So if you go through your textbook, you will see those terminologies that I'm using. So you will be able to compute. If I'm looking for Molia, you can yourself compute what will be the address, because I know Molia is the third record. So if the first record starts at 0, I can add 100 to this record, another 100 to compute the starting address of the third record. So I know that it is at 201. But whereas in random access, I don't know, because system creates that address. I don't create that address. System internally creates this address. So the disadvantage of random access is this: there is an overhead of creating or using the hashing algorithm to create that address, right? So there is a disadvantage. What is the advantage? The advantage here is this: the records, the records are not. So let me show you what I'm going to talk. So I want to cover a disadvantage before going to the advantage. So if you see, I put two boxes here. What it means is the first box is one buffer pool. What is a buffer pool? Buffer pool, I mean, is basically, let's assume it's like we are using to make it easier for you. Let me tell you, the system, let's say, internally uses two different drives to store. There is one hard disk and there's a second hard disk. Let's assume, for example, and if you go into mainframe technology, we use multiple hard disks within the system. So when it creates a hashing algorithm, F14 falls into one storage device or one hard disk. When I compute the address for the second record, K13 falls under the second device. So what it has to store the record in the second hard disk, let's say. Now, when I start looking, there may be empty spaces. Now, not even while looking, while storing. There may be empty spaces in the first device, but still, because my hashing algorithm says store the second record in location K13, and K13 is here, it has to go stored in the second device, though there is a space available here. Make sense? Is it too much confusing? Excuse me. So remember that Right. So I'm assuming I'm making it clear, okay? So hashing algorithm creates its own address. Based on the address, the data has to be stored, but the address could point to a location that may not be in the same hardware device, or may not be in the same buffer pool or logical unit, okay? So there is wastage of space. Even though there is space here, it's not stored, it's stored somewhere else. So there is wastage of space, okay? So we talked about two disadvantages here. Number one, there is an overhead of computing the address using a hashing algorithm. Number two, it is less efficient in terms of storage, because there is wastage of space, even if a space is available in one logical unit. So I know it's a little difficult, a little hard, a little dry, you know, but I'm trying to make it easier. If you guys think it's still hard, let me know. We can we can slow down or talk something different and then come back a little bit. But what I'm going to ask you guys is go through this. After I'm done with this session, I'm going to ask you to go through your textbook and correlate what I explained. So if you correlate what I explained, it's going to be easier. There may be a lot of content in your textbook, which if you go read yourself is going to be tough. That's why I'm trying to make some examples here and you know, try to put it using examples. Okay, so go through your textbook and correlate with this example. It's going to take some time. Okay, it's not easy, but you will get it. Okay, but remember my examples. What else we have? Okay, next. Next, we're going to talk about the advantage again. I don't know if we talked about it. The random access advantage is quicker access to your record. You know, all the three techniques within random access is they give you quicker access compared to serial and sequential. Okay, now let's talk about indexed sequential access method. Okay, now let's assume this records is deleted. For example, I delete this record. Okay, so now in the beauty of random access is this. In serial or sequential access, you know, if you're looking for a specific record, you get the specific record. So in random access, what I can say, look for record number 16. If you don't find, give me the next available record. Sometimes in practical scenarios, it's possible. You are looking for a specific record. If you don't find it, give me a closely matching record. Okay. There are practical situations like that. You know, I'm looking for somebody living in Hebal, let's say in Mysore, Hebal. But if you don't find somebody in Hebal, maybe give me somebody who lives around that area, right? Similar to that. So it's not a direct search. You're doing a direct search, but if you don't find an answer to a direct search, you're still open to go something something outside of it. You know, you are open to go a little bit. So you're open to go a little bit beyond that particular match and look for a record. So I'm looking for record number 16. If you don't find record number 16, please go to the next record. Okay, so that is where a beauty comes here called ISAM. ISAM stands for Indexed Sequential Access Method. The first ISAM, ISAM. ISAM stands for Indexed Sequential Access Method. Okay, indexed, you know, we talked about what is index. We talked about index in the beginning. The fields are sorted. It's like a key field. I can search based on the key field. Okay, so what's the advantage of the key field? I can directly go fetch a record. That's why it's indexed. What is the sequential here? So this is confusing, right? You're talking about both indexed and sequential. How could it be both? This is confusing, right? Yes. So some file organizations allow you to do both. You can do indexed as well as sequential. That is what is this file organization. This is possible in random organization. So what it does, you can index to record number 15. So I'm saying index to record number 16. So directly go to record number 16 and from there start reading sequentially. Okay, so that's what I mean here. So go directly to a particular record, record number 16, and from there start searching what I want. Right? Make sense? So this is called indexed and sequential because it's indexed because you are going directly to a particular record randomly. You're going straight to a record and then you're saying start searching from there. If you don't find that, keep going down and then find a closely matching record. Okay? Or sometimes it may be like this. I'm looking for example, Rishi. I'm looking for the student Rishi. I don't know if Rishi is here in this group. I'm saying look for Rishi, but I know his record number comes somewhere after 15. So I'm telling the system not to look for the first 15 records. I'm sure Rishi is not part of those. Rishi is not part of those first 15. So start looking from the 16th record. That is where it comes helpful. So anytime where you need both the advantages. You can go directly to a record and start searching from there downwards sequentially. So go randomly to somewhere, start searching sequentially is called ISAM, Indexed Sequential Access. I'm going to take a real break. I know it's too much, but I want you guys to assimilate and understand this. If this is not clear, what part is not clear, I would be happy to go through it another time. I don't have any problem going through it. If you ask me 4 or 5 times, I don't mind to go through it. Let's take a short break for next 5 minutes, and then if you guys want to go through some of it, come back. Meanwhile, I want to talk something outside of the subject. So let me do something here.